Hello again, welcome to Mr Maths Revision, and I'm Mr Maths, and we're going to look at another mathematics video of integration. And this is about exam standard for the Welsh board and the English board. So let's have a look at the question here. We're looking at the indefinite integral of the root of x plus 1 over x squared minus the cube root of x. Firstly, what I do is simplify root x. Well, you may know that the root of x is x to the half. Now I simplify 1 over x squared because we don't want to integrate that just as it is. So what we do is we bring the x to the top and we change the sign of the index. So 2 on the bottom becomes minus 2 on top. Whatever is on the bottom goes to the top and you change the sign of the index. Now we have the cube root of x. So that's x to the third. We now have terms under the integral sign here, which we can now integrate using the formula that we did in previous videos. What we do, as you remember, is we add 1 to the top, so that's x to the half plus 1 over a half plus 1. We do the same with the second one. We have x to the minus the 2 plus the 1 over minus 2 plus 1. We do the same again with the cube root of x. We have a third plus 1 over a third plus 1. And again, don't forget the constant right on the end. So what we do now is simplify. We simplify the first term here and we get x to the 3 over 2 over 3 over 2. We simplify the next one, we x to the minus 1, because minus 2 plus 1 is minus 1, over minus 2 plus 1, which is minus 1. And then we get minus x to the power of, well, you've got a 1 and a third, and of course 1 plus a third will give us 4 over 3. So that's 4 over 3 over 4 over 3. And then again, don't forget the constant on the end. What we need to do now is to simplify each of the terms. What I say anyway is if you've got 3 over 2 underneath on the denominator, if you invert it, then you'll have 2 over 3 x to the 3 over 2. All you do, if you like to think about it, is take the 3 over 2 and you turn it upside down and put it in front of the term. This second term here, we've got x to the minus 1. Well, we don't want to finish off the solution here with the x to the minus 1 on top, so we actually bring it back underneath. We've got a minus here, we've got 1 minus sign, so there'll be a minus there. And if you take the x to the minus 1 down onto the denominator, we change the sign of the index, just as we did in the very beginning when we took x to the 2 from the denominator back up to be x to the minus 2. So x to the minus 1 now goes to the denominator here and becomes x to the plus 1. And the final term here, we invert the 4 over 3, we tip that upside down and we put minus 3 over 4 in front, and we get x to the 4 over 3 plus a constant. What we've done is to simplify the last line for our integral. Let's just talk about this before we finish. Can we just scan back up to the integrals there? The x to the half was quite okay because we just used the formula x to the n plus 1 over n plus 1, and it's a half plus 1 over a half plus 1. The 1 over the x squared was the difficult one, so we simplify that to be x to the minus 2 to begin with by taking the term to the top and changing the sign of the index. We didn't like the cube root of x, so we turned that to x to the third. And of course, if you go through then the integral process, we had x to the minus the 2 plus 1 over minus 2 plus 1, and for the cube root of x, for x to the third, we have then the minus x to the third plus 1 over a third plus 1, and of course plus the constant on the end. And then we did indeed in the conclusion simplify by inverting the fraction there. It's a little trick really to think of. You've got 3 over 2 and you tip it upside down and put it in front of the term, and you get 2/3 of x to the 3 over 2 minus 1 over x minus 3/4 of x to the 4 over 3 plus a constant. Well, that's mainly how they would leave the answer in the examination, although these terms can be simplified just a little bit, which we may do in a further video for you. Well, thank you very much for watching the integration solution, and I look forward to tutoring you again in the next mathematics video. Thank you very much. Goodbye.